So now let's start tackling how to find the electron configurations of those elements specifically located within the D block. And this is where a lot of people can get confused with because there's a small twist to this. Before we get started, let's start off by numbering our rows like we did in the previous example. And let's denote this as the letter N. So in the previous video, when we found the electron configuration of carbon and sulfur, we used this coefficient, the number of the row that it's in, to denote the 1s, 2s, 2p, and etc. But when we get into the D block, it's actually not going to take the same number that it's in the row. It's actually going to be 1 minus that. And what I mean by this is we start looking into D block elements within the fourth row, correct? So we're going to still do 4s, but when you get into the D block, it's not going to be 4d. This is the mistake. It's actually going to be, remember, 1 minus that, so it's going to be 3d. And then we go back to 4p because s and p orbitals take the coefficient, take the row that they're in, but the D block takes 1 minus that. The same thing applies when you're in the fifth row. It's going to be 5s, 4d, 5p. And we'll understand this more by doing a few examples. So let's just take vanadium for now and note down that it's got 23 electrons. So to start the electron configuration is going to be the same way as we started in previous examples. You always start with the first row in the s orbital and figure out how many elements are in the first s orbital, and there's 2, right? The hydrogen, helium, so it's going to be 1s2. Then you start in the second row, and how many are in the second row in the s orbital? Again, 2, so it's going to be 2s2. And remember, you have to go through all the elements till you reach the one, our vanadium, which is in the fourth row. So you have to go through all of these. So how many do we have to go through in the second row in the P block? 1, 2, 3, 4, 5, 6. So it's going to be 2p6. Now you're in the third row, which is the same thing. 3s2. Now you still have to go through all of these, right? So it's going to be 3p6. And now we're in the fourth row. So it's still going to be 4s, and there's 2 elements in there, the potassium and calcium, so it's going to be 4s2. And now remember, it's not going to be 4d, it's going to be 1 minus that, it's going to be 3d. And now you just have to figure out which column the vanadium's in. In previous example, we also named the columns in the P block as 1, 2, 3, 4, 5, 6. So we can do the same in D block, except now D block can actually go all the way up till 10. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And you just have to figure out which column vanadium's in, and it's in column 3. So it's going to be 3d3. And again, as a good way to check that you did it correctly, add up all the superscripts. 2 plus 2 is 4. Plus 6 is 10, plus 2 is 12, plus 6 is 18, plus 2 is 20, plus 3 is 23 electrons, which is vanadium. Hence, you have the correct electron configuration for vanadium. Now let's try doing another example so that we really know that we have this drilled down in our head. Let's just take boron over here. So, again, it's going to be the same thing as I did before. I'm going to kind of speed it through at the beginning because I think we kind of understood how to do the whole beginning part. So it's going to 1s2, 2s2, 2p6, 3s2, 3p6, and now it's the fourth row that gets tricky, right? So it's still going to be 4s2. And remember, you have to go through all the elements until you reach the one which our bromine is all the way over here. So you have to go through all these elements in the D block. So there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, right? So 3D, remember, it's a 3, D10, then you go back to the 4, and which column is bromine in? It's in the fifth one, so it's going to be 4p5. And you're going to see that once you add up all these superscripts, that it does equal to 35.